We're going to cover two sections in Chapter 6. One is 6.1, the area between two curves, and then we're also going to do average value. So this is the area between two curves. There's three main topics. We're going to do area between two curves with respect to x. We'll do area between two curves where they switch who's on top and who's on bottom, so you have to divide it into pieces. And then sometimes it's easier to integrate with respect to y instead of with respect to x. So that's the broad overview of this section. Now remember that area under a curve can be described by the integral. So if we wanted the area between two curves, we could go through and motivate that exactly like we did the integral with rectangles to approximate it, Riemann sums, let the number of rectangles approach infinity, and we would end up with an integral. So it's the integral from one end of the region to the other end of the region of the top function minus the bottom function. Easy enough. Exactly what you would expect it to be. Let's look at an example. The area of the region bounded by y equals e to the x above, below by y equals x, and on the sides from x equals 0 to x equals 1. Always sketch a graph first. If it's challenging, then you can resort to Desmos, but try to do it by hand if you can, because you know on test day, no Desmos. So, I would expect you to be able to sketch the graph of e to the x. Doesn't have to be perfect, but you know, woo, it looks like that. And it crosses the y-axis at 1, because e to the 0 is equal to 1. And we're going from 0 to 1, which is why I only made the first quadrant. And then y equals x looks something like that. So we're trying to find the area of that region. So what we do is we find the area of the entire region, and then we subtract off the area underneath the line. Integral from 0 to 1, and I'm going to name it A for area. Move that down some. 0 to 1 of the top function minus the bottom. And this is easy to integrate. E to the x minus x squared over 2. Evaluate that from 0 to 1. So we have e to the first power minus 1 squared over 2 minus e to the 0 power minus 0 squared over 2. So that gives me e minus a half minus 1, so e minus 1 1/2, my final exact answer. There's the pretty solution. Let's do another one. Example 1 was friendly. It told me exactly what my limits of integration should be because it said it was bounded on the sides by x equals 1 and x equals 0. Example 2, not so friendly. It just says to find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. Luckily, again, easy to sketch. And you notice I'm only sketching above the axis because I know that y equals x squared is the generic parabola that looks something like that. Y equals 2x minus x squared. Now, I know that that is a downward facing parabola, but I don't know exactly where it lies in the xy plane. Let's set these two equal to one another and see where they cross. So x squared is equal to 2x minus x squared. Well, I'm going to add x squared to each side, subtract 2x from each side, then I can factor out 2x. So x is equal to 0, or x is equal to 1. So I know that, we'll call this 1, 0. I know it crosses at those two places. Now, I don't know anything else about it. Maybe this is the vertex, maybe the vertex lives between there somewhere. Just because we can, let's review the easy way to find the vertex. Turn on your calculator, get rid of the old stuff. Go to the PolySolve button and put in your formula that you need to solve. So y equals negative x squared plus 2x. Looks like I already have it in here. Negative 1. Let's go back 1. Back. There we go. B was 2. C is 0. Exactly. Solve. That's not what we want. Keep pressing enter, and eventually it tells you exactly what it would look like if we had it in vertex form. A times x minus h plus k. A is negative 1, that's the leading coefficient. H is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. So, the vertex here is the point 1, 1. Anytime you want to get an idea of what your equation looks like, a quadratic equation, you can just plug it into the PolySolve button and let it do all the hard work for you. So I know downward facing parabola, that looks something like that. And I'm going to find this area right here. I know my limits of integration are 0 and 1. My upside down one is on top, so 2x minus x squared minus x squared, which is the integral from 0 to 1 of 2x minus 2x squared. Then leave myself enough room. So integral from 0 to 1 of 2x minus 2x squared is add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. And it's always extra nice when one of my inputs is 0, because all I have to do is plug in the 1. If it had units, they would be squared units because it's area. Your x is whatever the units are, and your y is being measured in the same units. So you have x times y gives you units squared. Alrighty. So far they've been very straightforward. We can also use the area between two curves to do application problems. if we have the birth rate of a population is given and the death rate is given, find the area between the curves from 0 to 10 and what does it represent. So quick picture. Again, I'm only interested in what's happening from 0 to 10, so I only need the first quadrant. They're both exponential curves, so they both go whee up in the air. B crosses the y-axis at 220, at 2200. And D crosses the axis at 1460. So I'm just going to say it looks something like this, and I'm moving my 10 because I made them so steep. Doesn't really matter. It's just that area between the two. So we are told that we want to know what's happening between 0 and 10. We'll have birth rate, which is the one on top, equals e to the 0.024t minus d of t, which is 1460 e to the 0.018 dt. And now I will integrate. Easy to do. If you do need to go back and think about u substituting, u would be equal to this exponent. You're just going to end up dividing 2200 by the coefficient times e to the 0.24t minus 1460 divided by its coefficient times e to the 0.018t, and take that from 0 to 10. I'm going to pause and do the arithmetic. Okay, I plugged it in, did all the arithmetic, and then I wrote up the sentence that this area represents the difference between the birth rate and the death rate. So it is the net increase in population during the first 10 years. Now, just as a little reminder, on test day, to be sure you get it right, you can always go in and plug it in as an integral. I think I did that on here. Yeah. So just plug in the integral from 0 to 10 of the first function minus the second function, and it'll give you the answer. And I may not make you do every single one of them by hand. If it is something that I know you can do by hand, that you've already shown me that you can do it by hand, I might not even make you do it. So have your calculator handy and practice checking those answers with it. WebAssign.